Hi everyone. In this lesson, we're going to talk about composite functions. And a composite function, think of it as a fifth operation. So we're all familiar with adding, subtracting, multiplying, and dividing. But composite functions are considered another type of operation where we take a function or a number and place it inside another function. So if you think about the word composite or composed, it means to be made of. So it's a function made of another function. So we have this symbol, it looks like a degree symbol, but it's actually the composition symbol, and it's read f composed with g of x. Which is just g of x placed inside f of x. We'll talk about the domain in just a little bit. So let's say we have a function f of x equals 2x squared minus 3 and g of x equals 4x. And we need to find f composed with g of 1. So that just means I need to find f of g of 1. So I'm going to work with g of 1 first. We're going to work inner to outer. So g of 1 just means you're going to take the function g of x and evaluate it at x equals 1. So all I'm going to do is replace the x with the 1, and 4 times 1 is 4. So g of 1 is 4. So now I'm going to replace g of 1 with 4 and find f of 4. So that's going to be 2 times 4 squared minus 3. Remember, order of operations, so you have to do powers or exponents before you multiply. So I need to take care of the 4 squared first, which is 16. And now I can multiply 2 times 16, which is 32, and subtract 3. And I get 29 for my final answer. For letter B, I'm finding f composed with f of negative 2. So that's just f of negative 2. So I'm going to find f of negative 2 first. So in the f of x, I'm going to plug in negative 2 everywhere there's an x. Negative 2 squared gives us 4, and 4 times 2 is 8. And 8 minus 3 is 5. So f of negative 2 is 5. So now I'm going to find f of 5. And that just means now I'm going to take the same function, and everywhere there's an x, I'm going to plug in a 5. So 5 squared is 25, times 2 is 50, minus 3 is 47. In another example, we're going to look at a table, and we're going to use that to evaluate composite functions. So in letter A, we have f composed with g of 1. Which is just f of g of 1. So I'm taking g of 1, my answer for that, and plugging it into f. So first I need to find g of 1. And if I look at the g of x row, I need to find where g is 1. So my answer there is 0. And then now I need to replace g of 1 with 0 and find f of 0. So now I'm going to go to my f of x row and find where f is, or where x is 0, and the answer is negative 1. Okay, let's try the same thing for the next one. So in the next one, I'm looking at g of f of negative 1. So I need to find f of negative 1 first. So I'm going to go to my f of x row and find where x is negative 1. So that would be negative 3. And now I need to find g of negative 3. So now I'm going to go to my g of x row, find where x is negative 3, and I'm getting 8. And for letter C, I've got g of negative 2. So now I'm going to do the same thing, go to my g of x row, find where x is negative 2, and I get 3. So now I'm going to find g of 3, so keeping with that same row, and this time going to 3, the value I get is 8. And you all can try the problems that I'm leaving behind, and if you have any questions, you can ask me. This is a very similar problem, except you don't have a table, you just have a graph. You still have your ordered pairs. Okay, so I'm going to highlight the two functions. G of x is this curvy graph. And then this graph here, this green one, that's going to be f of x. Okay, so in letter A, I'm finding g composed with f of negative 1, which just means g of f of negative 1. So I need to find f of negative 1 first. So I'm looking at the green graph, and I'm finding where x is negative 1, which is right here. The y value next to it is 1. Now I'm going to take g of 1. So now I'm going to go to the purple graph and find where x is 1, and the y next to it is 4. For letter B, I'm looking for f of g of 4. So I need to find g of 4 first. So I'm looking at my purple graph where x is 4, which is right here. And my y value that I get is 2. And now I want to find f of 2. So I'm going to look at my green graph. And I'm going to find where x is 2, which is right here, and the y value is negative 2. Okay, let's talk about the domain. So we have to remember that when we are finding domains of composite functions, that a composite function is a function that contains another function. So the domain of the function that you're plugging in, so let's say we are looking for this, f composed with g of x, which is just f of g of x. That's telling me that I'm plugging g of x into my f function. So whatever the domain of g of x is, it has to work for the domain of f. So if the domain of g of x, let's say, was all real numbers, but f of x was a rational function, such as in this example, you have to remember for rational functions, you always have to be careful with the denominator. You at times need to restrict the values of the domain because you never want your denominator to be 0. So if you're looking at f of x in this problem, if x was negative 2, negative 2 plus 2 is 0. And you don't want that. So that domain would need to be restricted. But if g of x had a domain of all real numbers, you could see where there could be a problem because all real numbers includes negative 2. But you can't include that for f. So kind of to keep this as simple as possible, there's two possible steps when you're finding the domain of composite functions. You want to first find the domain before simplifying. And then if you can simplify the composite function, and not always you'll be able to, but if you can simplify it, you'll want to simplify, find the domain after you simplify. So it's a before and after. Sometimes, like I said, you won't need step number 2. So let's take a look at this example here. It says, suppose f of x equals 1 over x plus 2 and g of x equals 4 over x minus 1. Find f composed with g of x and find the domain. So here I'm looking for this. So I need to take g of x and put it inside the f function. So f of x is 1 over x plus 2. So in place of x, I'm going to just put g of x because that's what the composite function's telling me to do. It's saying take g of x and put it inside f. So where that x is, right here, I'm going to replace it with g of x. So I'm putting 4 over x minus 1. Now to simplify something like that, okay, we're going to have to use a little algebra. But before we simplify, we want to find the domain. So here, where I need to be careful is where the denominator equals 1. So I'm just going to take my denominator and set it equal to 0. And you get x equals 1. So that's a bad thing, because if x was 1, you would have 0 in the denominator of that fraction, and that would make it undefined. So we're going to have to remember to restrict our domain and not use 1. So x can't equal 1 here. Now we can try simplifying. So to simplify, I would never leave my fraction or expression like this. What I'm going to do is I'm going to multiply the numerator and denominator by this denominator here. By doing that, when you go and distribute this x minus 1, they're going to cancel out for that portion. So if I multiply across on the top, 1 times x minus 1 is just x minus 1. On the bottom, when you multiply 4 over x minus 1 times x minus 1, the two x minus 1 quantities go away, and you're left with 4 plus, and now you have to remember to multiply 2 times x minus 1. And then we're going to go through and simplify that even further. So I'm going to have to distribute my 2 and then combine my like terms. That's the simplified version of that composite function. Now, I need to look at my denominator again, and I need to set that equal to 0, and again, find what value I need to restrict the domain. So here, -1 is a bad number. If x was -1, your denominator would be 0, which would make the fraction undefined. So now for my domain, it's going to be all real numbers except x can't equal -1 and +1. For b, I'm finding f of x. So here I'm taking f of x and plugging it back into itself. So here, again, I have my x, and then I'm going to replace that with f of x. So I'm going to, before I simplify, set that equal to 0 and solve. So I know x can't equal -2. Okay, that's a bad thing. And I also know that I need to simplify this now. So I'm going to multiply the top and the bottom by what? If you said x plus 2, you'd be correct. Okay, again, it's whatever the denominator is. So now you're going to multiply the top and the bottom by x plus 2. So 1 times x plus 2 is x plus 2. And when I multiply the denominator by x plus 2, these will cancel, and I'm left with 1 plus 2 times x plus 2. And then again, you're going to go through and distribute the 2, and combine like terms. And now we're going to find the domain again. So we're going to have to find where we're restricting our values, which would be at -5/2. So my domain is all real numbers x such that x can't equal -2 and -5/2. Okay, you can pause the video and read the example if you want, and then unpause when you're ready. The manufacturer of a computer is offering 2 discounts on last year's model computer. The first discount is a $200 rebate, and the second discount is 40% off the regular price P. Write a function f that represents the sale price if only the rebate applies. So a rebate's just another form of a discount. Usually you'll pay for something in full and then you have to send away or send something to the company, like usually a form completed that will take more money off your the cost of whatever it is you're buying. So here I would be looking for f of p, right? And we're using p like x. P is just price. So when I write my expression, I have to use p instead of x, okay, for p for price. So how would I represent the sale price if you're getting a $200 discount? Well, if your price is p, you're getting to keep $200. So you're taking the price and subtracting 200. And that's your final sale price. It's just p minus 200. So in other words, if the price of the computer was $1,000 and you sent away for a $200 rebate, you would really only be paying $1,000 minus 200 or $800. The next function we have to write, we're going to call it g of p. And this is if the 40% discount applies. So to find a discount, we multiply the price times that percentage. So we have a 40% discount, and we're going to move the decimal back 2 places to the left. So 40% is just 0.40. So to find the sale price, I'm going to take 40% of the price, but I'm going to take that away from the actual price. So it's the price of the computer minus 40% of the price, leaves me with the sale price. And you can actually combine like terms here. 1p minus 0.4p is 0.6p. So really, g of p is equal to 0.6p. So in letter C, it says find f composed with g and g composed with f. What does each of these functions represent, and which combination of discounts represents a better deal for the customer? Sometimes you save more by doing the rebate than the discount. Other times it's the discount and then the rebate. So if I find f composed with g first, that's really just f of g of p. So I'm taking g of p and plugging it into f. Okay, so g of p is 0.6p, and I'm plugging that into f. So f is p minus 200, and I'm plugging g of p in for p. So g of p is 0.6p. So really it's just 0.6p minus 200. Okay, and this represents when you take the discount off first, then the rebate. So this part is the discount. You're paying 60% of the price, then the rebate of $200. So then to find g composed with f of p, it's g of f of p. So now I'm plugging f of p into g. So g is just 0.6 times p, and in place of p, I'm going to plug in f. So if I simplify this, I'm going to distribute 0.6 times p, And then 0.6 times negative 200 is negative 120. Okay, and this is when you have the rebate first. So here's the rebate. You're getting the price minus 200, the $200 rebate, and then they're taking 60% of that. Okay, so which one's the better deal? So if you look at both of these, you can easily see they both have a 0.6p, but this one subtracts $200, whereas this one's subtracting 120. So which one's the better deal? It would be the rebate and then the percent discount, because here you're paying 60% of the price, but you're oh, sorry, just kidding. It's the top one, because you're getting 60% of the price, but then you're getting an additional $200 off, as opposed to the second one, which was the rebate and then the discount, where it's 60% off and you're only getting $120. So the discount and then the rebate is the best deal. Okay, and that one was the F composed with G of P. So that's the end of 6.1. If you have any questions, please reach out to me, and also make sure you have completed your homework. Hope you all enjoy the rest of your day.